And welcome back. Now today we're going to be looking at the Wemos D1 Mini, that's this thing in the center of the board here, okay, because quite frankly it was a new item for me. I'd already used the big ones like this one here at the back, or indeed this one. They're both Wemos D1s, full size. Why they're different I have no idea. They both say they're release 2 I think on the back, and if you do go for a full size one, do try and get the D1 R2. The D1 R1, although I don't think it said R1 at the time, it's just the D1, is in fact now retired. And the main reason being that the R1 had 2 buttons on the front, unlike this one which just has a reset. It had a reset and a flash. And when you tried to upload a program, you had to hold the reset, hold the flash, let go of the reset, keep holding the flash until it took hold, as it were, and started to flash the memory. It was all a bit faffy about, quite frankly, and a lot of people got a lot fed up with it, and even me. I must admit, when I used to upload sketches to the old style Wemos D1, it was probably about a 50-50% chance of whether or not it was actually going to upload or not that time. So these R2 versions have got around all that, both these boards here, but the Mini, which is this one here, and it's functionally equivalent to this one here, was brought to my attention as part of the ESP8266 deep sleep video that I did a little while ago. Yeah, let's not talk about the way it goes into deep sleep, because I was a little bit surprised that's the way it did it. But the actual board itself, I was unaware that they made a Mini like this. But there were a few comments in that video saying this is what I use, and it's great because it's got obviously built-in Wi-Fi, which you need for anything, Internet of Things. You can put it into deep sleep mode. It'll run for weeks, if not months, on something like this. This is an 18650 battery, in case you're not totally familiar with these. I don't know what. Oh yeah, this is an ultrafire. Well, it says it is on the packaging. Whether it is or not is another matter, isn't it? And it's an 18650. It's certainly not 5,000 milliampere hours. It's probably about 1800, something like that. But it's a reasonable battery, this one. Now, if you've read my blog, you'll have known that I connected this up to the shield that you can put onto this device. So it's this one here. So this is a little Lipo Shield. You plug this battery with this plug into that socket there, and then plug your USB into there to charge it up every now and again, and this will then supply the power for your Wemos D1. That's great, except then I put this on a metal dish. It just sort of accidentally fell on it really, and it started to get very hot and melt some wires. And indeed the battery got very hot, so I suspect it discharged quite a few amps in quite a few seconds. I mean, and unfortunately the magic smoke may have escaped from this one, but we'll play about with it a little bit later and just see how well it works. There is an alternative way to power your Wemos D1. Obviously you can power it directly from the micro USB socket on the front, or you can have one of these power units. So this is the power unit, very, very similar to what you might find in the Arduino Uno world, right? The jack input. This one has a voltage range of, if we can just catch that, 7 to 24 volts. It just says it in there. You can probably just catch that, 7 to 24. I'd be careful about the 24. Don't push these things to the limit. But I can run it on 12, and it doesn't seem to have any problem with that at all, as you'd expect it not. Now, most of these items, not these big boards, but most of these little ones were supplied by Banggood, because when I read about the Wemos D1 Mini, I thought, hey, this could be quite a good little video to do, and Banggood agreed. So they supplied most of these items for free in return for a video, and also there are some links to each of these items underneath this video, so down there. And should you want to pursue following any of these, all you've got to do is click on those links, and that actually is an affiliate link that gives me a small amount of commission. I've no idea how much. It's not going to be a huge amount, but every penny counts, as that means I can buy more stuff like this for future videos. So let's see what we can do then. Now, this Wemos D1 Mini came with a variety of options for soldering on these headers. So which one should you in fact use? As you can see, I've used the longer stackable header, which is used all the time on shields for the Arduino, but is in fact the right one to use for the Wemos D1 Mini. Well, my logic was I didn't want this to be the first one in the stack. I thought we could have this one, which is the power input, as the stack, or indeed the Lipo module, this one here. So power is the first one, then we could stack this one on that one, and then maybe this one here, which is a I2C temperature shield, I believe. Yes, temperature shield. But the very top one obviously must be this one, which is the TFT screen. In fact, it's not a TFT, it's an OLED screen, or OLED screen. Okay, it's only a tiny little screen on the top, but it could be quite useful for showing you the status of various things. It's not, I suspect, designed for like primary use, not like, say, a Raspberry Pi might be used their screens, which are very, very nice, as a primary display. This is simply to tell you perhaps what's going on in that module that's locked away in a cupboard somewhere, counting bees in a beehive, for example. So if we were to take the simplest route and say, well, we won't use that power, we'll use this plug-in power for now, we'll use this one and this one, plug them all in together, and let's see what happens. Now, when you're plugging all these in together, of course, it's quite important, well, make that very important, that they're all plugged into the right orientation. So make sure that your pins with the TX is always at the front. Now, unfortunately, the actual Wemos has the antenna bit sticking out here, so that could confuse you, thinking that is in fact the other end, which is here, which is, you know, normally pinless. So just keep your eyes on that one. So let's plug this in. It's a standard ESP8266 by all other means, really. You can run any ESP8266 sketch on it. Obviously, this hardware for this is a little bit bespoke, but once again, you can use the Adafruit library for this, and that's, you know, it'll be fine for what it's intended for. So all we need is a 12-volt supply. Oh, and this, if by magic, here's my 12-volt plug-in. So we'll plug that in down the bottom. So we'd expect something to happen, maybe. Oh, look at that. And there's a clock. Well, all right, I cheated a little bit. I did, in fact, upload a sketch to the ESP8266 Wemos D1 Mini beforehand, just to prove it worked. In fact, first thing I loaded, as always, was a double blink program, which in the Wemos or the ESP8266 world, remember that the output for the LED and so forth is reversed. So high means off and low means on. So the double blink wasn't so much a double blink, it was a double off, if that makes sense. So it was permanently on. The little blue LED that's buried in there somewhere, it was mainly on, but it proved that it worked. So I thought, great, now I've got that running, I can upload further sketches. Now I'll put a snapshot of what the settings need to be to upload to this, and we're using the standard Arduino IDE for this. We're not using Eclipse or anything else at the moment, just to make it clear exactly what we have to do. So let's have a look at the settings in order to upload any sketch to that Wemos D1 stuffed in the middle there. Right, these are the settings then that I used. Some of them, I must admit, I guessed a little bit, but let's see how well it works. First of all, you got the board Wemos D1 R2 and Mini. So there we are. That says it all, doesn't it? Same board really, just a different form factor. Flash size 4 meg. Now I've chosen the 1 meg spiffs rather than the 3 meg spiffs because we're not using spiffs anyway, so why allocate more memory to it? Yeah, debug port was disabled by default. Debug level was none by default, left those. The lower memory thing there, I'll have to read up about that because that's a new thing that's popped up in this release of the Arduino IDE, or at least for this board anyways. I don't know what that means. CPU frequency is fine, it's 80. Upload speed, now I had to change that. That was set to some ridiculous thing like 900k or something. Didn't like that at all. 115200, that's about the maximum the Arduino IDE normally supports. Erase flash, now that means when we upload program, a sketch, do you want the entire chip erased, including any data, any EEPROM stuff, whatever? Do you want the whole thing erased, or do you just want the area occupied by the sketch erased? Now by default I believe it is only sketch, so that you can have a sketch running that writes away to EEPROM and has some values there, for example. Then you can update the sketch but not touch those values. So by default it says only sketch, so I've left it as that. The port is whatever port you've connected to. I think mine's 12, and that's it. Oh yeah, the programmer of course is AVR ISP Mark II, because that's your Arduino IDE effectively. So those are the values to use. They worked well for me. You may have to tweak some of them, and I'll look into that, the IWIP variant, to find out exactly what that means these days. Right, so that's that. So the next thing to think about, apart from showing you the prices and things that I've got on here, is the whole point really of an ESP8266 anything is that you want to control it via the internet. Either you want to connect to it, or you want it to be able to supply you with some data on a web page or something like that, either on your phone or on your browser. Now we've covered a few things on internet-based web pages. I did one for the Arduino with its LAN shield on it, and it's just not very different from that at all. So we'll get something up and running apart from this clock, which is a nice demo, but apart from showing you a clock, it's not of that much practical use, is it? So let's get something else working on here, something to do with the wireless. After all, that aerial there is looking at us, taunting us almost, to say make use of me. So we will. Okay, here's the little sketch that I've had around for ages. Now I can't work out whether I wrote this or whether it's just one of the examples. It's the sort of style I could have written, but I don't know. There's not enough comments in it, I don't think, for it to be my code. Maybe I've tweaked it. Anyway, it doesn't matter, it's all open source. So what this sketch is actually doing is creating a little Wi-Fi server. That is to say, this little device is serving up web pages. Okay, now it's not, how can I say, it's not like a web server you'd find, you know, in Amazon or something. It's a little tiny thing, but it's good enough to give you an indication of a status of something, like a switch or a temperature gauge or something like that. However, all this is doing is showing you the status of that LED there, whether it's on or off. And as you can see, it's brightly lit at the minute, and that's fine. Let's see exactly what this is generating as a web page, and then we'll come back to this code. All right. So in our browser, here we are. So I've connected via my browser to my local network. Okay. So if we look at this address here, 1.84, 192.168. That's always your local address. 1, yours might be 0 or 2 or something. And 84, it's just been allocated 84 as its number. Now it says in big letters, LED pin is now on, and it is on, as you can see. And we can click to one of these two things here to turn it on or off. So if we click this one here, where it says turn it off, and off it goes. Now there's no smoke and mirrors here. This is all done via the internet. It's not via this USB cable, and we can prove that by unplugging this USB cable and plugging in our alternative method of power, which is this one here, just to make absolutely sure that we are running off the network. Let's do that. So here's the power about to connect. On it goes, and once again this is now running. Now what you're seeing on screen here on the browser, of course, is old. It's from 30 seconds ago, isn't it? So let's refresh that by pressing F5 and making sure we can still connect. Now, so it's still connecting, and now it's saying off. So let's turn it back on again with this one here. There we are, on and off, as if by magic. And as you can see, the only thing that's connected to this device now is the power. So it's all via the local network, your home Wi-Fi, effectively. So this could be buried once again in that ubiquitous beehive at the bottom of your garden, powered by, I don't know, a solar cell or a lithium ion, something like this, or anything you like. But it does need to be connected to your Wi-Fi, as long as your Wi-Fi range extends to the bottom of your garden, of course. And you could be interrogating not the status of the LED, but perhaps the, I don't know, the weight of honey, or the temperature in your greenhouse, or the level of water in a water tank, something of that ilk. Now, it's all very interesting turning an LED on and off, and at least it does sort of prove the point that it does actually work. Oops, if I connect it there, on, off, okay. So yeah, we've proven that this definitely does work. Let's find out how it works behind the scene, and this is the standard way it would work for a full-size ESP machine. So something like this, it would be exactly the same. Right, let's have a look at the code and see what it actually is doing. Right, so back we are on the code window, and this is the standard Arduino IDE. It's all very familiar, isn't it? So what we've got here, first of all, we have to include this library, ESP8266 Wi-Fi. Now, the ESP8266 over the last couple of years has come a long way in compatibility with the Arduino IDE and the support. What you must do, though, is to make sure your boards are up to date. So go to Tools. You're looking at my monitor screen now because you can't see the drop-down menus either. So Tools, Board. Now we've selected the right board. That's fine. In fact, it has changed. It does say Wemos D1 and D1 R2 and Mini. And in fact, if you look at the first bit now, it says Lolin in brackets Wemos. I don't know. Anyway, the point is though, you have to go to Boards Manager and let it wait for a little bit. It'll load this up. Might take a minute or so. But then what we're looking for is the ESP part of it. So at the top, you can either type in ESP in your filter, except it's not actually letting me do that at the moment. Oh, hang on, that's why. It's downloading a load of stuff. I don't know if you caught that down the bottom, it was downloading stuff. Now we can type in ESP here as a filter, or just scroll down until you find it, which is what we'll do. Now this is the one of interest here. Now let me zoom in on that so you can see what it says. Now this is the ESP core library support. Okay, written by, well, the community these days, but it's for the ESP, so it works with the Arduino IDE. Now as you can see here, this says version 2.4.2 installed, 2.4.2 installed. Now previously I had 2.4.1, I think it was, and it didn't work, or at least say when I compiled the sketch that you can see in the back there, I got lots of errors. It said, no, I can't find this anymore and that, and I thought, hello, it's been a while since I've called up this ESP sketch, but surely it should still work, but it didn't. Things have changed. So all I did then was to say, fine, okay, on this board, this version, it said 2.4.1, there was an update over here, update button. It's gone now because I've pressed it and it has updated to 2.4.2. So make sure they're up to date, and every now and again come back to this screen, you know, every 2-3 weeks. If there are any updates, the Arduino IDE will normally notify you. You'll get a little prompt somewhere down here, okay, and it will say, oh, you've got some updates to your boards, and it's always a good idea to have a look what it is updating. Obviously if it's an update to, I don't know, Digistump, for example, this one here, and you think, oh, I haven't used it, I'm not going to use it yet, you can ignore it. But for the ESP, obviously that's one we're interested in. Right, so let's close that. So the ESP8266 Wi-Fi library is required. You need your SSID, you need your password, which obviously I'm not prepared to tell everybody about here. Now the Wi-Fi server, what port do you want it to run on? Well, all internet ports for the internet are run on port 80 if they're not secured, and this one isn't. So it's not an HTTPS web page we're generating, it's just HTTP. But 80 is what we're going to use, so we don't have to fiddle about with the address line in your browser. We just keep it at 80 and everything just works. Now we're setting the built-in LED. We're connecting to the actual Wi-Fi now by saying start connecting, use that SSID and password. If you've typed them in wrong, it won't, otherwise it will. And while it's doing it, you'll get a little dot printed every half a second. And well, eventually it will say the server, okay, I've started now. I've started my server, my web server on your network, and this is what you need. Use this URL to connect. It will display the URL. So in our case, remember, once again, if we go back to our little browser window that we had up there, 192.168.1.84, that's the thing that will be displayed when this is running. Now, it's all very simple and it's straightforward, and, well, normally it should just work, okay, quotes. Just make sure you get your boards up to date, and it almost definitely will. Then what it does is just read the incoming web address line up here. If you notice, there's more after that 84. Let me go back to the code window and zoom in on that a little bit. So at the end of this 1.84, there is more stuff. So if we make this bigger, there we are. Now you can see there's a bit of an argument there. Now in a commercial environment, you probably would not want to do this. This is where you're exposing some of the parameters of your website in the URL itself. Now that's fine for what's known as a GET command. That is, you're just retrieving information. So if you're going to Amazon and retrieving information for, I don't know, shoes or something, it wouldn't really matter if it said size equals 10 or something there, right? It's just not critical. But you wouldn't want to expose anything critical here, especially given that this is not a secure site. We haven't got HTTPS invoked this time. Okay, now what the code then does is to say, right, I'm reading that little bit off the end, the /LED equals off or on, and let's just move this out of the way a little bit. What it's saying is, look, it's looking here for LED on, and if it doesn't find it, it turns it off, and if it does find it, it must be on, so it flips or toggles the LED value. Now this is a little bit clunky, but it's just to prove the point, and it works fine. Right, now this is all very well, and yes, as a demo, great. If you haven't done this sort of work before and you get this far, you should congratulate yourself that you've actually got something working over your home network. But turning an LED on or off isn't the most useful thing in the world, is it? Let's think of another sketch which we can use, perhaps still using this sketch part of as a sort of a basis, and perhaps display something a bit more useful like the temperature perhaps, or humidity. What if we can do that? So what I've done then is to connect this Wemos SHT30 shield to the actual ESP D1 Mini, powered underneath by this, but of course we've got it connected at the moment to the USB because I've just uploaded a sketch and I'm just praying that it works because I've not even had a look at it yet. Yeah, I think it's time we undid this then. Take that off and connected it up to the power. And doesn't seem to be any indication of life, does there? Let's hope it's all hanging together here. Right, let's have a look at the code then. What I've done, I've actually used the foundation of the previous sketch that we saw, so it's connecting still to the Wi-Fi. I've added in this little bit here now, look. Oh yes, and there's another include somewhere. Where's the other include? There it is. So there's another include, and all these libraries, I'll point in the video description down below where you can find all these. I wasn't going to faff about and try and write my own library for this, and it's only it's half a dozen lines, it's nothing. So we need that library for the actual device itself. This is how we get the object, and to get, okay, here we connect to the Wi-Fi again, exactly the same way as we always did, but now we go and get the temperature and all the rest of the gubbins. You can get it in Celsius, Fahrenheit, humidity. I think there's a couple of other values you can get as well, but for a demo that'll do. We're saying, right, if the client connects, and this time you don't have to send any values, you don't have to send that LED on or off, because we're not talking about LEDs. It's just like the client has requested that page, okay, just like you would do out on the internet. So it says, oh right, okay, you've requested something, I'll send you back the HTML for that page just the same way as we always did it, but I've changed that last line now. Instead of saying about the LED bit, I've said, right, the temperature is Then I've read the temperature out of that module, that object that we've already requested at the beginning of this, and print it. Then I've said, and here's the humidity, and go and get it out of that object and print it, finish it all off, and well, that's it. And then disconnect and wait for a second, because you can only convert the values on here about once a second. And let's face it, I mean, if this really was measuring the temperature in my beehive down the bottom of the garden, would I care whether it's 5 seconds out of date even? No, I wouldn't. So that's absolutely fine. Now, if you're wondering what all this gobbledygook is here, that's HTML, and some of it is a little bit obtuse. Even if you know HTML, sending it back a response type like, well, up to here, you have to get that bit right. Then your page starts with HTML and your head and your title, and I cannot possibly start teaching HTML in this demo. It would take me about 6 months to get you up to speed. So there's a little task for you. But it is pretty simple. You can just use this and experiment and Google it, and you probably get more than enough of a pretty page. I haven't made the page any prettier than what it was, so I guess it's time to see if this works. I should have tested this before I started a video, shouldn't I really? Never mind. Right, browser, where's my page? Alright, that's the old one then. So if I hit F5, so all this is going to go, right? We're not talking about LEDs. F5 and I better put it into focus first. F5. Oh, look at that. Brilliant. I don't know if the values are right. 28 in this workshop. Oh, it's because I'm probably holding it down. Okay, let's see what happens then. If I stick my thumb on the sensor down there, like that, the humidity value, 41. Well, it might be. I don't know. In the UK, we just don't seem to take a lot of notice of humidity unless it goes really humid, 89%. And even then, it's just not one of the things that's reported widely on the weather stations. Anyway, let's refresh that. So I'm just refreshing. The fact it's got LED on out here now is absolutely nonsense. We don't need any of that, so I can take all that off and just hit that. And it says 33. Oh, the humidity's gone up as well. Probably my sweaty little palm around it, you see. So, well, we can only assume it's working. I'll just repeatedly hit F5. Well, it's going up to 33. I thought it might go up a bit hotter. Let's try my other finger. Perhaps my other finger's a little bit clammier and hotter, and it might make the values a bit different. Right, let's have a look. F5 and... oh no. Oh no, it's not doing it anymore. I've probably disconnected something. As you can see by the little twirly thing in the tab up here, it's trying to connect to this, but is currently failing. That's what happens when you put your fingers all over it. Alright, we'll try it again. Alright, kill that one. Let's try it again. Or this might be a case of hitting reset. Where's the reset button? On the side. That's lucky. On this version, the reset's actually mounted sideways, so we can reset that like that, and hopefully it will all spring into life in a minute. And if not, we'll just reset, send that again. Oh, there we are. We're back. 29.97. Fine. Okay. Well, we'll just assume that it's accurate. So there we are. That's another useful thing. Now that is actually, okay, yes, the web page isn't particularly great, is it? But that could easily be buried in a beehive or a greenhouse or something like that, and measure the temperature remotely because it's all on Wi-Fi. As long as your Wi-Fi, of course, reaches that far. Okay. Well, that's a fairly good example of what can be done. And we've had a look at the OLED screen, TFT, even though it displayed a clock, but I mean the principle was there, wasn't it, really? I guess what we ought to do is plug in the this and power it from something separate than this, because if this was in a beehive and it was too far away, I'd have to use a battery. Now, yes, I would normally have to put it into deep sleep. So what would happen is you power it with the battery, goes into deep sleep, and maybe once every half hour or something like that, 15 minutes, it would do exactly this, what it's doing on screen. It would go and read the temperature or something like that, and then go back into deep sleep mode and post those values somewhere where I can get hold of them. Or if it was running permanently, be prepared to charge this up, sort of, you know, daily or something. I don't know. Right, let's change the underlying shield, the power shield, and see if it still works and that magic smoke hasn't escaped yet. Just before we connect up the power shield, there's something I want to bring to your attention. When I saw this, I thought, oh yeah, that's neat. Connect up the Lipo into there. That's a Jst connector. Ordered those, which are these, from Banggood the same, but of course these don't fit. And why not? Well, let me get one out and show you. So this is the connector, pretty standard for I don't know, drones and cars and things for power. Reasonable thickness of wires. Okay, fine. But of course, when you get to this will not go into there because it's too big, isn't it? Look, I mean, I couldn't get that in at all. So I'm thinking, what is that then? If it's not a Jst connector, well, actually, what it is one of these. It's a micro Jst connector. So that caught me out actually, and in some ways, I'm not so happy about this. This micro Jst connector, yeah, that's fine, and it fits in there. If only I could do it. Let me do it off screen. Right, I had it upside down, that's why I wouldn't want to go in. So that goes into there just fine. The wires, though, are, I don't know, they're a little bit thin. They're certainly thinner than these ones on the standard Jst one. Not by much, but a little bit. But worse, if you look at the layout here. Now, when I discovered that these were too big, I thought, well, it doesn't matter because it allows me to put in a couple of header pins at the top here and use those instead. Now, the first thing that should strike you at this point is, hang on, the red's over here and the black's over here, but the red's here and the black's there. Something dodgy go on. Well, I know this is working, the header pins. One I was very sure about which one I was putting it in. And it's these cables, actually, which I didn't get from Banggood at all. This is not Banggood's problem. This is a local store I bought them from, or at least local in the UK. And they've actually wired these up back to front, it would appear. So on my power unit with the Lipo on it, so this one here, if you notice, I've had to switch around the cables. Now, I don't know if there's some oddity going on with polarity here, or whether it's just these micro JSTs that are the wrong way around, but I mean, that would cause problems. Well, quite severe problems, in fact, really. So something to be aware of. And in fact, I'm not going to give you the link for these micro ones in the UK because I think there might be a problem with those. So we just quietly hide those away and pretend it never happened, and then we had the proper ones. But obviously, if I was to connect that up as it is now, that would, well, potentially, I don't know, it's providing reverse polarity, isn't it, to this device? That's the problem. Right, a couple of days late because I did try out this lithium-ion buck converter, and I'm afraid it's FUBAR, which is, as everyone knows, stands for fried up beyond belief, because yes, this is fried. It sort of works in the sense that if you plug the lithium into here and the USB into here, the red light goes on. But then very shortly after that it goes off, and it doesn't convert the other way around. So it doesn't convert the battery into 5 volts if you disconnect the USB. So this is, as I said, FUBAR. Shame, really. And well, one of two things happened. Either it all went bad when I placed it into the metal dish, but if you remember, I said I'd put the battery leads into here straight as they came out of the packet. So this one here, for example, it goes in with the groove at the top, so like that, and as you can see, the polarity is reversed. Now, it's only for a fraction of a second, but who knows? One of the two killed it off, though. So, back into the recycling dish in the sky you go. Pity, because I like this one from Banggood a bit better than the other one, because this one allows you to put a couple of pins in here if you want to, and wire things up in a more permanent fashion. But there we are. So I had to rush a replacement from a local supplier, local as in UK, and luckily it came, and it is different. If we look at the two side by side, although they're ostensibly the same, you know, same size, same format, sockets in the same place, polarity is the same as well. Obviously the components are different in themselves, and I'm not going to go into what the component differences are. It's just not relevant at this stage. But it's still going to be a buck boost because we've still got the same chip on here. We've still got the coil and a few other unnecessary components that we're not going to talk about. Okay, so that's what that does. Now, so what I've done then is plug the lithium ion into that socket. If we plug the USB, this is just a standard USB. I've not actually put it into like a charging socket or anything, not at the moment. Make sure I get the polarity right here. Oh dear, there we are. Now you can make out that the LED red light has gone on, which means it's charging at the moment. Onward and upward then. So this is all powered up and it works. This is red now. It goes to green when this is fully charged. Okay, but we haven't got time to wait because I don't know how many amps I sucked out of here by frying that thing at the back there. Not that one. It's gone. This one here. By frying this one. But obviously it took some power out of it. So it's charging it back up. Now what I want to do is connect this onto here, and quite frankly I'd rather do that without any power being connected. So let's disconnect this one here, holding the plug. Ooh, blue light. Okay, right, making sure we get our orientation correct. So the TX and all that is at top right. So we plug that into there. I think these pins are getting a little bit bent now. I keep unplugging them. Right, push those down. There we are. That's enough. Yep. Right. So now, if we just connect the battery, it should in fact fire up. Oh, it does. Oh, there we are. A little face, a little image that changes. Or it's not supposed to change. In fact, when I look at this live, it's totally non-changing. Here we're getting this rolling display. Probably something to do with the refresh frequency or my lighting or something. No, it's that rolling bar that you can see going down the image does not happen in real life. I can't see it if I look past the camera. Not to worry. Anyway, the battery's powering this now, and the thing you notice in here, look, nothing's lit up. No LEDs are lit up either on the power supply board nor on the ESP itself, as there's no little blue light coming on or anything, which is exactly what you want if you were thinking of running this in deep sleep mode, running on a battery for weeks on end, which is great. I like that, I must admit. That's good. No, you don't have to desolder anything. It's cool. And then every now and again, of course, you want to come along and charge it up. So that one goes in here. There we are. So that goes back to red because it's charging, but would go green when it's finished. And that's it. All done and dusted. Pretty good. Yes, I like this this whole little setup really of stackable things. Obviously, you don't want it stacked up too far. But for an individual project, if you think, right, I need an ESP, I need an LCD, or in this case OLED, I need some kind of power that's either like that or like that, or just plain USB plugged directly into there. There's the sensor, by the way. So you have options, and as I showed you in the parts lists from Banggood, they do many different options, some of which I felt were a bit too long-winded to demo here. And talking of long-winded, I realise this video's gone on a while, so I think we'll call a halt there. This works. I've uploaded another BMP to this just to show you we can really. It's not exactly practical, but who knows? It could be a sign, couldn't it, to say error or stop or something. Cool. Okay, that's it then. That's sort of an introduction to the Wemos D1 Mini series. Thanks very much for watching. Don't forget to put comments down below. YouTube like it when people comment. It shows that there's an interest. Thanks very much. See you in the next video. Thanks for watching. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.